In this video, I'm going to talk about the data structure known as a linked list. And so a linked list is a dynamic size ordered sequence of a specific type. But what makes it sort of different from just a regular list is that it's a list with pointers. And so a pointer is the address or index or name or object or whatever you want to call it in the heap of the item pointed to, not the next value. And so this is sort of a common way of looking at linked lists. So you can think of this thing in the middle here, the A1, the A2, the A3 as being sort of like the values. And then these little boxes to the left and right are the pointers pointing to the next object, the next thing in the linked list. And so, yeah, each thing in the linked list, they're called nodes in linked lists, contains a value and a pointer. Well, in doubly linked lists, like what's shown here, I guess it would have two pointers, a pointer to the next and a pointer to the previous node in the list. All right, so each element has to be the same data type, which is pretty standard for these for most of these data structures here. So these syntax for it, so we have linked list, data type in the angle brackets, the name of it, new linked list data type. And so we can have it with int or float, character, string, so on and so forth. And you can also have it be reference types like classes as well. And so this is another sort of common kind of illustration you'll see. So a linked list, so it's dynamic. Adding nodes increases the size of the list, and removing nodes decreases the size. So not stored next to each other in memory, so they're in the heap. So arrays are like this. So each element of the array is sort of next to each other in the memory of the computer, where the linked list looks like this, where you have the value A here at this point in the memory, then this pointer points to some other place in the heap. All right, and so some linked list methods. So if we have linked list name, we can have clear. This removes all nodes from the linked list. We have the add last, and so you add the value here, and it adds a new node containing the specified value at the end of the linked list. Then first adds a new node containing a specified value at the start of the linked list. There's also add before and add after, and for these ones you have to use linked list node type data here, and I will show that a little more explicitly here in a few minutes. So we have add after, so that's the linked list node type as well, so you add after a specific node. Then we have find, so that will find the value that you input here, so it finds the first node that contains the specified value. So we can use for loops to iterate through the elements, and we can make sure the loop begins at or near the first index. We can use for each loops here, so data type M in our linked list here, so it'll iterate through the elements of the list. And so this is kind of what the these add methods are for. So we have our linked list here, LL name, so we have LL name, and so this is blank right now. When you first make it, there's nothing in it. So you do LL name dot add last, and we put 2, and it adds this here. So I drew like this, so this box with a 2 in it is our value, then this arrow here is our pointer, and it's pointing at null, so it's pointing at essentially nothing. So then we can do add first with 0, and this sort of adds this thing right here. So the red is the thing that was just added here. So it has the value of 0, and now it's has a pointer pointing to this next node here. Then we can do add last, and this will put this here at the end, and it will have this pointer pointing towards null. Then so what we can do is we can do link list node int current, and then do ll name dot find to. So it makes this reference value here called current, and that current will be equal to this node with its pointer right here. So we can use this linked list node here. It's stored as this current here. Or we can use var current equals ll_name.find. So remember, var and then this are just kind of the same thing. And so then we can use the add after, and we'll use current, which remember the current is this right here. And so it'll add after that. So yeah, so the current is what I have in blue right here. So then it adds after that right here. So this 3 right here. So it sort of inserts that right into this linked list here. Then we have ll name add before current and put 1. And so now we add this right here, this 1 with the pointer now going to the current, and so we end up with this 0, 1, 2, 3, 4 as our linked list. And if this was more accurate, I should have actually used double arrows on each of these with another null sort of pointing towards the left this way, because this is actually a doubly linked list. So you can actually use next and previous to actually get to forward and backward nodes in the linked list. All right, so nodes, and so this is actually for a singly linked list here. And so the reason I'm showing this is because if you use LeetCode, which if you are learning a code, I would highly recommend, it basically gives you puzzles that you have to try to solve with code. And whenever they use linked lists on LeetCode, they use these singly linked lists, and they give you code that looks like this. So this is one of their nodes right here. So they call it a list node. And the reason I kind of like using this here is because it kind of shows, I think, some of the inner workings of what's going on with these nodes. So we have this class here called list node. Then it has these two fields right here. So we have val for the value, and that's an integer. And then we have list node next. So this is pointing to another list node called next. Then we have this right here. So this is our constructor here. And so this is just setting values to these. And so what you see here is using this keyword this, and so this just points to the object, and so in this case it's just pointing to list node. And so instead of like using a name for whatever this is, dot val equals val, it's just saying that we're talking about the sort of current object that we are in. And so that is what this means. And so like I said, this code right here is something you will see if you use LeetCode. So the list node class has a public int val set to the int value from the constructor first argument, and the list node class has public list node next set to the list node type from the constructor second argument. So it is initially set to null, but the list node can be added to it. All right, and so let's take a look at how we can do this with code. I'm actually going to turn this back to dark theme. All right, and so this is just looking at the sort of built-in linked list thing going on here, and I'm just going to kind of go through this rather than typing it. So we have this method up here that's making our linked list. So we have this linked list integer, and I'm calling it the method llmaker. So right here, it just makes a linked list called list. Then we see here I'm using this method add last. So this is just kind of going through the way that I did it in the presentation. So this just adds the first element to the first node, I guess, to the linked list. Then add first will add 0 before that. Then add last will add 4 after that. And so when we use this method, which is what we will do right here in the main method, that's what it will do. And so what I have going on here now, so we see I've linked list node int current equals ll dot find 2. So this creates this current, which is a data type link list with a value of 2. Then I'm using the add after and add before, just like I showed in the presentation, with current with 1 and 3 there. Then so I'm going to comment this out so we can just look at what this is doing with that. So this is just going to print each of these out. And so we see we have 0, 1, 2, 3, 4. So those are the 5 elements we added. The first 3 up here, so the 0, the 2, and the 4. Then we added the 1 and the 3 right here. Then this for each loop is just printing out the value in each node. And so what I have right here, so I'll uncomment this. So this will actually, this is something else you can use to sort of navigate your linked list. So this current dot value will print out the sort of the value of current, which remember is the 2. Then we also have current.next.value, and so that will print out the next one, and then .previous.value will print out the one before it. So this one should print out 2, this one should print out 1, and this one should print out 3. So if we run this, so current 2, next 3, previous 1. So you can use these next and previous properties for this here to sort of navigate through your linked list as well. And so then we can look at some of these other methods here. So we can use the contains 3, and so this will just print out true if it contains 3. So we can do remove first and remove last, and then this will just print out the linked list after it has had 0 and 4 removed. So it contains 3, true, and then 1, 2, 3. We removed first, which was 0, and removed last, which was 4. And so those are some of the things you can do with the linked list. So I'm actually going to comment this out, and then I'm going to look at this and uncomment it out. So this is actually looking at this leet code type thing here with the list node. And so what I have here, so this is actually based on one of the leet code problems, which is just removing a number from a linked list. And so that's what this method will do right here. So this code up here will actually remove the node that has the val that's specified here in this parameter. Then this part will just print out what is left. And so down here we have our main method. So this up here is just saying that I'm going to use a random number between 1 and 10 that will be removed. And so this right here will just tell us what our value actually was. And so we have list node head equals new list node. So I'm just instantiating this class up here, this list node class up here. And so then I'm doing list node body, and I'm setting it equal to head. And so because this is a reference type, the body and head now point to the same data. So when I do something to the body node here, like add another node after it, it'll do the same thing to the head node. But the reason we want to do that is because we want the head node to remain the first node in our linked list, so that when I feed it here into our method, that it starts from the first node of our linked list. And so what I have going on here, so we do body.val equals I, and this is starting from 1 and going to 10. Then then this right here will make another list node that's body.next. And so we see up here, next is another list node, but this is setting it to null. And so it's null until we actually make another list node right here. And then we set body equal to this new list node, and it will iterate back through again and set the next value to 2 as it goes through this iteration. So here we are instantiating our solution class, which is what I have the method in up here. So this remove elements method right here. And then it will take this head, which is the first node of our linked list, and then the value that we want to remove from the linked list. And so remember, the head here, so everything we did to the body here, because this is a reference type, has also been done to the head. But the head, the reason we want to do this part right here, why we want to make body, is because we want head to remain the first node of our linked list. So when we feed that in, it starts at the first node and then points to the next node that was added when we were adding it to the body here. And so I know for me, and this is why I did that video on reference data types and value data types before. I hadn't actually learned that the first time I tried working with these list nodes on Leet code, and it just confused the heck out of me. I was like what's going on with this step? Like how does this work? How do I make this new thing and then have it, do stuff to this this head object here? But that is because it is a reference type, and so we're actually doing the same thing up here in this method here. So we're making this list node myln, and we're having that equal to head. And so remember, everything we do to the myln, which is what we will be doing here, is also happening to head because it is the reference type. And so this is going to look at, so while the next one is not null, this is going to look through this linked list. And so if our myln.next.val is equal to value, then we set myln.next equal to myln.next.next. And so we're essentially skipping over one of the nodes if it is the value that we are trying to remove from our linked list. And so that's how it's actually removing it, is it skips over the node, or it's essentially, skipping over and just removing that node that we don't want right there. Otherwise, we will just do myln equals myln.next, so keeping that next node in there. Then right here, we will just print these out. And so if our first node was our value, then well, if the first node is the value and the next one is null, then this will just skip the next node right here. But what we see, so remember, I have this set so that the value is chosen randomly, but the linked list will have numbers 1 through 10 in it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so if we run this code here, so our value is 7. So we look here. So 1, 2, 3, 4, 5, 6, 8. So we removed that that 7 node there, then 9, 10, and then because it will go to 10 of them, it will do that 0. So when it gets to that null one, it will just print out a 0 there. So we can try this again. So the value is now 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. And so we see that it's removing those nodes from our linked list. And so the other thing to just to remind you, this right here is a singly linked list. So we would need another thing right here, so like another public list node previous, if we wanted it to be a doubly linked list like what we were doing over here. But anyway, that is what I wanted to talk about for linked lists in this video. I hope you found this helpful, and I will see you in the next one.